Hello and welcome. It was Financial Modeling World Cup this weekend. So I've been in the habit lately of trying to post a video of my live attempt at some or all of the questions after the round. I thought I'd do something a little bit different this weekend. I don't know about the rest of you. This round felt like it was going basically smoothly for me up until halfway through the last question. And then it totally went off the rails. So I thought I would do a what I wish I had thought of for that second half of section 3. That second half, to give you a sense, was like less than a third of the marks. It took me longer than everything else put together, and I still did worse on it. So, quick introduction to the question, and then I'll give you a quick sort of tour of the model I actually built, and then I'll show you how I would build it now. So, general introduction to the question: you run a brewery. You have 6 different beers that you brew, all with witty, punny names. You have 12 different tanks in which you can brew beer in any given month. You have various contracts that you're obliged to meet. So 4 different pubs, each of which has demands for different number of kegs. So 3 large kegs, 3 medium kegs, 1 large keg, 1 small keg, etc. in each different month. And then after that, you have your own kind of brew pub that has a certain kind of starting demand and a certain growth of demand for each month after that. And the idea is first, you got to brew the minimum amount you need to fulfill all your contracts. Second, to be a reputable brew pub, you need to have at least 800 servings of each of your 6 beers on hand. So, whatever you have left over from the minimum brewing for the contracts, if that's less than 800 servings for any given beer, you brew another tank of that beer, and that in most cases takes up sort of 8, 9, or 10 of your 12 tanks. That leaves you with 2 to 4 left over. And you want to optimize the most revenue you can make out of those by selling any given beer. So in other words, if after the leftover demand, after the leftover supply, after meeting your contract and brewing your minimum amounts, there's still demand for 2,000 pints of, say, Jar Jar Gabor, and one tank is 1,240 pints, then you could make 1,240 times the price per pint of Jar Jar Gabor by brewing Jar Jar Gabor. You figure out how much money you could make by brewing each of the 6 beers. You take the biggest one, you brew that, rinse and repeat until you've used up all your tanks. So 2 main kind of twists in this. One was how to model the optimization, and the other was how to work with this sort of messy pub demand data. So I'll give you a very quick tour of what my model on the day looked like. Key theme here is it's going to be considerably larger than what I'll show you today. So here we've got, you've basically got 3 different dimensions in your data. You've got months along the side, months along the top, beers down the side, and then separate blocks for each pub. What you'd really prefer to have is something more like a database format: a column for pub, a column for beer, a column for month, a column for order, and then you could work with that however you need to. But I did not decide that was the best way to tackle it on the day. Instead, I just laid out, here's a block of how many small kegs are ordered by each one. There's some twists in the formulas, but that's not really the relevant piece here. Here's how many medium kegs were ordered for each beer from each pub in each month. Here's how many large kegs from each beer in each pub in each month. Total number of pints, which is just, multiplying the number of small, medium, and large kegs by the number of pints for each keg. And then an overall total number of pints. The revenue by month, which is just a function of where have we got it? Yeah, we got it here. This is no, sorry, well, anyway, doesn't matter. Again, I don't want to really show you the workings of this one. I just want to show you the layout. So we've got the revenue by month, total revenue, then we've got the total number of small, medium, and large kegs, the cost of each of those, and then the total revenue. So that's that piece. And then the rest of the model, I built it all on the assumptions sheet, which is not ideal practice, but never mind. This is basically all built in blocks of month along the top by beer down the side. And I just gave that list of beers the name beers so that I could, basically every time I made a section, I could just type equals beers and have that laid out and then fill in the formula. So, here's the contract demand, the number of pints of demand in the contract. So, in April, the total demand from all the pubs for Jar Jar Gabor is 1,240 pints. Convert that into how many tanks of each do we need to brew, then how much is left over after we brew a tank, which is 1,240 pints, and then fulfill this demand. And here's the answer. This is what's left over. Convert that into servings, because, some of the beers have multiple servings per pint, and we're interested in a minimum of 800 servings. So this is how many servings we have, and then if any of those are less than 800, then we brew another tank of that. Total number of tanks used. Then this is the excess supply. So in other words, for the contract tanks and the minimum supply tanks, you add those together. Total amount we've brewed, subtract off what is supplied to the contract, and this is the supply that's left over. And then you compare that to the brew pub demand to see, okay, this is the excess demand. These were fully supplied. We don't have demand for any more than that. These we have excess demand. Convert that into how much money could you make by brewing a tank of any one of these, and you say, okay, this is the biggest one, so we're going to brew a tank of Jar Jar Gabor in April. And then you carry on down, basically rinse and repeat to say, okay, after tank one, this is the demand that we have left over. So in other words, these have all stayed the same, but this has been reduced by 1,240 because one tank is 1,240 pints. And then again, we figure out the maximum revenue we can make from each beer. Which beer do we brew? One quick note here is that there was some nuance. Here we are, for example, some nuance around tiebreakers. I did, the case didn't say anything about how to split tiebreakers, and so in this case, for example, where two beers were equally revenue generative, I just made them both. Now, in theory, that could end up with a case where you have one tank left and two beers are equally profitable, so you brew them both, and you've actually brewed 13 tanks and it goes wrong. I did check to make sure, and we always ended up with an even number of tanks. And if that was not the case, I'm sure the case would have specified how to handle tiebreakers. Anyway, so then we repeat that for tank 3, for tank 4, that's the total number of tanks there were. As you can see, bad decisions you make, or decisions that wouldn't help this to be a replicable client model, I just deleted the entries for the ones where, in other words, this entry was here, then I ended up with -1 tanks left over. I said, okay, boom, now there's 0 tanks left over. Now it works, which it does in some sense, very, very unscalable. But, that's what you do in competition. So then you figure out total production. You figure out how many pints does that mean? How many pints went to the brew pub? How many pints did the brew pub sell, which is the lower of what went to the brew pub and the demand for pints there. And then whatever you didn't sell there is sold at reduced to clear. And then you can kind of add up the total revenues. Now I made a small mistake right here. When I figured out the pints for the brew pub, I took the total production and then I subtracted off the total contract production. So in other words, if there was demand for 500 pints, well, the smallest you can brew is 1,240 pints, so you'd brew 1,240. That's your contract production, but your contract demand is only 500. I subtracted off the whole contract production when I was figuring out what was left over for the brew pub, which made my ultimate answer wrong, although most of my model workings were right. So think of this as, if you basically fix that mistake, fix this cell reference to something else, this model is basically working, but as you can see, it's huge. And a little cumbersome, and it meant, having things laid out in so many different places meant that it wasn't easy to just sort of look across and see what was going wrong when my total revenue number didn't match what it was supposed to, and so I ended up just kind of giving up on debugging that. So I've talked before about how this kind of default layout of categories down the side, months or periods along the top, and then just block, 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 block. I think it's the most kind of natural way to build a model in Excel, but it's not always the most user-friendly. So the last time I talked about that, I think it was on Anup's leasing case last year. I basically did the equivalent of building one model per beer. It was like one model per unit in the apartment block or something like that, and then I replicated that model a bunch of times. In this case, you need to compare across the beers to decide which beer to brew, and so it's not ideal to build it by beer, but there's no carryover between the months, because whatever beer you have left over at the end of the month, you sell it reduced to clear, and then you brew new beer the next month. And so what you can do here is basically build a model by month, and that's what I ended up deciding was the better layout. So I've done some of the workings on this already, but I'll show you most of it. So first of all, here you've got your kind of table of a small keg is this many pints, medium keg is this many pints, a barrel is this many pints, a tank is this many barrels, a brewery has 12 tanks. I just, basically a barrel is not a relevant decision-making unit, so I just added pints per tank here and gave it the name PPT. And similarly, there's some kind of confusion along the way between pints and servings, so I just converted each of these prices per serving into a price per pint by dividing by the number of pints per serving. So here, for example, this is $6.50 per serving, but there's actually 4 servings in a pint, so it's $26 per pint. And then I don't have to worry about servings most of the time. I've already filled in this piece, which is just, previous month's demand times 1 plus the percentage change, simple. And the other thing I've done in advance is just named these. So I've named this, pub 1, this is pub 2. I've named this range beer 1, this range beer 2, and so on. I've named this month 1, this month 2, and then this block of orders here, order 1, order 2. Oh yeah, I guess the other thing I forgot to mention at the start is you'll see my keyboard strokes over here now. I set that up because I'm doing an esports battle on Thursday, and so you'll get to see my keystrokes there, but I figured I'd just leave it running while I'm doing videos as well. Oh yeah, the one other thing that we had to do here is convert this order number into a month name. A few different ways you can do that. The key piece is that, mid 3.3 of this is the 3-letter name of the month. And so then how do you convert that into a full month name? 2 options. One, if you know a little trick, oops, sorry, I'm missing my ampersand. If you concatenate a 1 onto the start of a 3-letter month name, Excel understands that as a date in some sense, and in particular, if you multiply by 1 to coerce it into a number, and then format that number as a date, it turns it into the first of that month in the current year, so 2023 in this case. So here we could say 1 times all of this to give me the month as a date number, and then we could also use text to convert that into the month name, carry that across. Or the other way, which is the way that I actually left in here from when I was playing around with this earlier, didn't mean to do that, is you can just look up the stub in any complete list of months, and all of these, month 1, month 2, month 3, all have the full list of 12 months. So the idea is you look up the stub, mid 3.3 gives you the first 3 letters of the month, and star, meaning anything that starts with 3 letters and then any other text after that. You look that up in month 1, returning from month 1, and option 2 gives you wildcard character match, which just means treat the star as any string of text rather than just as a star character. And then you can fill that across. So then, how do we unwind this? I've done some kind of setup here. So in particular, I've set up, this is how I want the pub to look. I want to have a database here with the pub here, the beer here, the month here, and the contract here. How do we do that? Well, with two-col, the easiest part is actually the block. That used to be the hardest part. Two-col order 1, and that just lays it all out nicely. So then how do we do the same thing for month and for beer? So to get this to work correctly, if you look at two-col, it reads across the row first. So this is all the first row. The first 12 are all the first row, and the second 12 are all the second row. So what I want is to have the 12 month names here, and then the 12 month names again here. And I want to have the first beer name in all of these 12 and the second beer name in all of these 12, but in such a way that when there's more beers, it will expand naturally. One easy way to do that, and this is a good kind of general trick to remember, is the idea is what you want is to produce a new array that is the same shape as the one with the data that you're unpivoting, that just repeats either the column labels or the row labels. And then once you have that, you can use two-col, and that will unravel that in exactly the same order. So in other words, Jar Jar Gabor will be associated with all of this first row, Alan Jar Jar Away will be associated with all of this second row, April will be associated with this column, and so on. So how can you do that? Well, one easy way to do it, you're saying I want to have this repeated as many times as there are rows in this. So one way that you can do that is you can say month 1 and so first, let's just say you can say month one and beer one, and that'll give you April Jar Jar Gabor. Then what you want is basically to retain the dimension of the beer, but not actually have the text of it there. And lots of ways you can do that, but one is to say repeat this 0 times, and that gives you your months laid out. And you can do the same thing the other way around. Beer one, month one, and that repeats the beer along here and the beer along here. So that's the idea. What does that look like when we come over here? We're just going to say to call month one and repeat beer one 0 times, and that unravels. So you've got April down as far as March, and then again April down as far as March, and then you do the same thing here, but just change this to beer one, change this to month one, and then similar thing for the pub, except that I mean, you could say, you know, pub one and repeat beer one 0 times and repeat month one 0 times, but an easier way to do this is to use expand. So we'll expand pub one, and how many rows do we want? We want one for each item in the block, which is count of order one. And if we just do that, it'll say, okay, here's pub one, and then it doesn't expand this far, so here's a bunch of NAs, but you can tell it to pad with the same thing, pub one, and now you got the pub name repeated. And now that you've got this set up, this takes a while when I'm chit-chatting through it, but not that long. But now you can paste that, replace 1 with a 2, replace all, and now you've got your data pointing to the second one, and then do the same thing for the third, replace with 3, replace all, and here, and replace with 4, and replace all. And now you've got all your data laid out in a nice way. So next question is, how can we extract the number of small, medium, and large kegs from each of these? So first thing that you can do is think about the number appears immediately before the letter every time. So we can say text before this, and so there's no S, there's no M, there's no L. So you can do error handling with text before. So just this last argument here, the whatever 6th or 7th argument is if not found. I'll just put a 0 there. So then we get 0, 0, 3. And then we could just put a minus minus in front of that. And that will work nicely for all of these. And it'll work nicely for the NAs when we get to them down here. But what it won't work as nicely for, well, won't work at all for, is these ones that have multiple values. So you can see it correctly extracts the S because the text, correctly extracts the L because the text before the L is just the number 1. But the text before the S, if we go to formula auditing, that's pulling out 1L semicolon space 1. So how can we deal with that? Well, you can take advantage of the fact that they're all, and you can kind of scan down here to see it, they're all 1-digit number of kegs. So the simplest way to do it is just to add a right on here. So you take the text before S, and then you take the last character of that, and that works nicely. Now, it's always interesting to ask, could you make this more flexible so that it could handle other orders? I think the first thing is to say, well, what if there were more digits? So something like, say, 13M, 45L, 200S. Can you handle that? Well, one way you could handle that would be to use the fact that it's split up by spaces. So rather than using right of this, let's just get our text before out, and we can look at that. So here's our text before. It's 13M, 45L, 200. So then we could say let T be text split of that by space, and just give me T. So now we get 13M, 45L, and 200, and we're interested in the last one because the last one is, we took the text before the S, so the last thing before that is going to be the number of S's. So then we just take from T, comma, comma, minus 1. And that gives you your 200, and then again you just need to put a minus minus on the outside of it, and that extracts those correctly. The one other kind of wobble you might want to be able to deal with is, what if people are a little less consistent and sometimes put a space. That's going to break some of these. You could also handle that with the fourth argument of text split, which is ignore empty. So let me just show you the text split here is outputting 13 m semicolon 45 200, and then the space is a separate or the kind of emptiness after the space is a separate thing here. But you can use the last argument, or sorry, the fourth argument of this to say ignore empties, and then it only returns out as far as the 200. So you can put that in here, and then you can handle any number of digits or any number of spaces. But like I said, in this case, it's not actually necessary, but sometimes I like to explore these things. And I guess maybe you do too if you're watching this channel. So here I've just pulled in the number of pints per keg of each size. So 40 pints in a small keg, 60, 100. And then we can figure out just as a sum product of these three with these three lock. That's our number of pints. Then our revenue. So we're going to look up the beer in the table of prices per keg. So there's the beer name, and here is the table of prices. So for example, Jar Jar Gabor is 180 for a small, up to 393 for a large, 394 to the nearest whole number. So that's that. And then we just need to multiply that by the number of each of them to get the revenues from each of those three. And you could just wrap that in a sum and go straight to total, but there were some questions about revenues from small or revenues from large or something like that. So there's also some value in spreading it all out, and that gives you your total contract revenues. So that's that piece. And then let's look at the model. Like I said, my ideal would be to lay it out as a monthly model with preferably a lot fewer values than the model I had before. So first I want my contract demand in pints, and we've just laid this out. And I think I gave, in this model, I gave the list of beers wherever it was, whichever one I named. There's a bunch of them. I just gave that the name B to make my formulas easier. So here I just type equals B. So then for my contracts, I'm interested in summing up things where the month name is this. So I like to grab whatever references I need from here before I go to a different sheet, so it doesn't append the sheet name there. So I'm interested in the total demand in pints, where the beer lock is B, and where the month lock is that one. So that's my contract demand. Then my brewpub demand. Like I said, I already filled this in here. Now this is your demand in servings. So you just need to multiply that by the pints per serving to convert it to pints. So here I'm just going to say index on all of this. Row number 0, column number is, so I've got my month selector driving the model up here, so that's in B2. And then I need to multiply that by the number of pints per serving, which is here. And that gives me my total demand for pints from the brew pub. Then how many tanks do I need to brew for the contract? Well, you just divide the number of pints I need by the pints per tank, and that gives me this. So here I need, for example, 0.47 tanks, 0.52 tanks, 0.34 tanks, and then I just have to round that up to the nearest whole, to the next highest whole number, which is 0 decimal places in roundup, to tell me, okay, I need to brew one of each of these, and that's actually just enough. This is the one that has the most pints demand, but 1240, as it happens, is exactly how many pints are in a tank. So next I need to figure out how many more I need to brew to get my minimum supply. So first, I'm going to do a little, rather than laying out lots and lots of columns here, I'm going to do a little documenting in the formula. So I'm going to say let excess let's not make the names too long. Excess contract supply be contract tanks times pint per tank. So that's the number of pints that you produce to meet the contract demand minus the actual contract demand. That's your excess demand. And I'll just put that in here for a second so you can see this is the demand in pints. Then I'm going to say if the x cont, and actually I'm going to add pint just to make it unambiguous. If that number of pints is less than, I'm sorry, the 800 should be in, yes, is in some cell here. Now that's the number of servings. So to get the number of pints that I need, I'm just going to divide, multiply that by this. So yes, if there's a quarter of a pint per serving, that means that to have 800 servings, I just need 200 pints. Yes, okay, so that's working. So if that's less than 800 times each of those multiples, then I need to brew one, otherwise I don't need to brew one, and we get this. So I need to brew more of these three where I brewed some but it wasn't enough, and I need to brew some of this one where there was no contract demand at all. So now, revenue optimization. So first let's do this one tank at a time just to make it easier. Tank 1, tank 2, tank 3, and then I'll show you how to kind of wrap it all up. So first let's think, what is the demand available before I brew my first discretionary tank? And that is the brewpub demand minus whatever is already left over from the contracts. And what's left over from the contracts is total number of tanks we brewed, which is this plus this. I'm not using sum because then it'll collapse it all down into one row. So I want to have 6 different answers rather than just one. So that times PPT is the total number of pints you brewed minus what you supplied to the contract. So here the excess demand is, here the excess demand is, you still have demand for 1,335 pints. Here you have just leftover demand for 200, 260, 680, and here it's gone negative. In other words, what you brewed to meet the contract already also met all the brewpub demand. So you're not interested in brewing anything else. So then from this, we would say, okay, how much money can I make? And I can't remember if I mentioned, but you're given the kind of servings price as dollar per serving. I've just converted that into dollars per pint, and I gave that the name DPP, dollars per pint. So I'm just going to multiply all this by DPP, and that is the revenue that I stand to make by brewing those tanks. Sorry, before I get there, I have to cap it because I can't make 10,000 from this, because to do that I would have to brew 1,335 pints, but one tank is only 1,240. So first I have to cap it. So let's just say let excess demand be this. Then we can say capped demand is if excess demand is greater than pints per tank, then give me pints per tank. Otherwise, give me, for now I won't deal with the zeros because those are kind of okay. Sorry, and then output capped demand. So now you can see my excess demand. This one went to 1335. Everything else stays the same. Now this one is capped at 1224. Oh, sorry, 1240. So then I'm interested in my cap demand times my dollars per pint. And that tells me I can make $9,300 by brewing Jar Jar Gabor, $5,950 by brewing Is There Life on Jars, $2,200 here, $1,700 here. And so then whatever we can call this max rev is that. And then we can say minus max rev equals max of max rev. And that'll convert into, okay, brew one of these and 0 of those, because this is the most profitable one. But let me just go back to where I had the max rev for a minute. Let's consider what will it look like when we get to the second tank. So sorry, here, let's just say equals minus, or let's do x match this against this equals, sorry, I'm confusing myself, don't ignore me. Minus this equals max of this. And that gives you your 1 there. So now, when it comes to the next tank over, it's going to be basically the same thing, except that we're going to subtract off one more tank of this. And so now that 9,300 becomes 713. These all stay the same because we haven't brewed any more of those, so the demand for those stays the same. And so again, let's just do it. So we get, okay, that we would brew one of those and then take this, put it further over, and then add that. Wait, what? Sorry, I'm doing something wrong here. Let's be a little more careful and just copy the formula because something is locked and something is not locked, so it's copying over in a funny way. There we go, plus this. And now we get this. So these are all now fully met. This is the most profitable one, and so on. You basically keep working your way down. So that is one way to think about it. But there is a neater way to think about it, which is, basically everything stays the same except the one you just brewed. So instead of thinking of it as, this and then mostly the same, let's just start off with what is the money we can make from each beer at the start, after one tank, after two tanks, after three tanks. What's that going to look like? So, boom, come down here. So, So here's come back to my excess demand for a minute. This is my excess demand. Now, what would my excess demand look like if I subtracted off some number of tanks brewed? So let's just say I think about 3 tanks starting from 0 times the pints per tank. So now my 1335 after 1 tank is brewed goes down to 95, after 2 tanks goes negative. These all go negative after 1. So let's put this in here and then put that into my cap demand. Oh yeah, sorry, I haven't dealt with the negative still. So let's say if my excess demand is less than 0, then 0. Otherwise, my X demand. And now we can see, okay, so, sorry, and then I still want to multiply my cap demand by my dollars per pint. So now we can see from the first tank of the first beer, we can make 9,300. From the second tank, we can make 700. From the third tank, we can make nothing. First tank of this one, we can make 1,700, then 0, and so on down. And so if I have, let's say in this case, I've brewed 9 tanks, I have 3 tanks left available. All I'm actually interested in, what are the 3 biggest numbers in this grid? And that is this, this, and this. And then you're done. And so there is an option, basically, rather than kind of laying each of these out, we just build this grid and consider where everything falls in that. So what's that going to look like? This formula is going to get big now because I am going to do it all in one. So let's just lay it out. So first of all, I'm going to need a variable, which is how many tanks do I have to brew. So let's just add in tanks, and that's going to be my total number of tanks, which is this 12 over here, minus the sum of the ones I've already brewed to meet my contract, which is F6 sharp, and the ones I've already brewed for my minimum supply, which is G6 sharp. So that's my total number of tanks. And then here, the most tanks I will ever consider brewing of one beer is the total number of tanks I have to brew. So that's, rather than just randomly thinking, let's look at, after 0, 1, and 2, let's look at everything up to the number of tanks. So now that's all humming nicely. What's next? Well, first of all, I can just replace this with max rev if I just multiply straight in here by dollars per pint, rather than calculating the cap demand and then multiplying by that. So here's my max rev. And now, like I said, I'm interested in the biggest things from this. So if I did not have to worry about tiebreakers, then I could say let T be this, then large T, whatever 3 was my number of So I'm basically interested in which ones are in the top 3. So I could say t greater than or equal to large T3. And so you can see it says this one, this one, and this one. And I could wrap that in a minus minus. And that would give me here, here, and here. And then if I really wanted to, I could do a by row of this to sum lambda x sum x. So in other words, just sum up each of the rows of that thing, and that tells me brew one of the first beer, one of the third beer, one of the fourth beer. 2 reasons not to do it this way. The first one is it won't deal with tiebreakers. So in a case where you have 1 tank left and there are 2 beers that are equally valuable for it, this will brew too many tanks. So you need to have a tiebreaker. And the second is that some of the questions actually asked for an order, like, what is the third beer that we brew under these conditions? And so just knowing that the output is these 3 beers isn't actually enough. So what do I want instead? What I want is to basically output the biggest 3, or the biggest n of these, where n is the number of tanks I have left to brew, sorted from high to low, and then give me the beer number of those. So similar to what I did with the unpivoting before, just imagine that I have here, whatever, sequence 6, and the same here and the same here. So then I could unravel each of these to row of all this stuff and to row of all this stuff. And then I could sort the list of numbers by the value that I can get from each one in descending order. And that says 1, 4, and 3 are the biggest. And then it carries on. So let me just do this, put this a little further down. Let's do sort this whole range, index 1, order descending, and we're going to sort by columns. So you can see the sort by gives me the same thing except without including this. So you can make 9,300 from 1, then 5,950 from 4, then 2,210 from 3, then 1,700 from 2, then 712 from number 1, and after that you stop being able to make more revenue because you've met all the demand. So this sort by gives me the numbers that I'm interested in, and then I can basically take from that the 3 that I'm comma 3, because I want to take columns rather than rows, and that'll give me the 4 beers in order. So okay, now first of all, how can I generate this block? Well, similar idea to how I filled out the other ones before. I can just say plus sequence, comma 3, comma 0, 0. So this gives me a sequence of 3 numbers starting at 0 in steps of 0. So in other words, 3 zeros. So it just basically makes 3 copies of that column. This is the sort of text equivalent of concatenating something that you've repeated 0 times. So where do we get to then? We want to say sort by to row sequence rows B. So B is our list of beers. So that's the 6 beer names. So rows of that is 6. And then sequence of that is 1, 2, 3, 4, 5, 6. So that plus sequence, comma, tanks, comma, 0, comma, 0. So we want to sort, basically take this block and convert it into a row like over here, and then sort it by max revenue converted into a row. So to row max rev, and the order is descending. And then for our output, we want to take, sorry, I didn't give this a name, so I'll call this sorted. And then for our output, we want to take from sorted, comma, comma, tanks. And that gives you 1, 4, 3. Those are the 3 tanks that you'll brew in order. So then I'm going to put those up there. And then for your revenue optimization, you can just say countifs this, hash. I don't even need to lock it in, just h2 hash for rows of B. So again, just basically how many 1s are in there, how many 2s, how many 3s, how many 4s, how many 5s, how many 6s, and that'll tell you how many of each beer that you brew. And then once you've got that far, finishing off the model, I'll just get rid of all these things that I put in as helpers to explain that. Finishing off the model is actually pretty easy. So this is the total amount you brewed. So how many pints did you make? It's this times PPT. How many went to the brew pub? Well, it's just this minus whatever went away in the contract. And sorry, I should say so that's how many were available to the brew pub, but you don't give the brew pub more than the brew pub wants. So it's the minimum of that and the brew pub demand. And then how many went reduced to clear? Well, that's the total production minus what went to the contract minus what was bought in the brew pub. So you can see some of them are fully in demand, others not so much. And then we need to work out the revenue. So for the contract, it's basically the same formula as over here, except instead of summing up the pints, which are in column H, we want to sum up the revenues, which are in column L. So L, and that's the total revenue from the contract. Revenue from the brew pub is going to be that times dollars per pint, and the revenue from the reduced to clear is going to be this times dollars per pint times 1 minus the discount on the reduced to clear, which is a 40% discount. And then we sum all this up, and that gives us our total revenue for the month. And then if you just want to quickly answer questions, then you can do you can figure out, okay, so what is it for month 2, for month 3, and so on. Or you can get every month at the same time with a data table. Column input cell is this. And then fill that down, and then we sum that up, not including the top row. And that says the total revenue is 1469169, which is in fact the right answer. And then if you want to, instead of doing it this way, you can build, repeating blocks of this model, one for each month. The only tweak I'd make here first is, rather than having a hard-coded 1, just make this the max of whatever is above it, plus 1. And that way, your next month's model will automatically expand. And then once you have a few copies of it, you can come back here and just speed things along a little bit by doing 3 of it at a time. And now you've got your 12-month model. And then you could easily, if you want, do a summary by month. Summary by month, which would be something like, let's just take my list of months here, transpose this, and then you could just say XLOOKUP this in your list of months, returning from. It's a little weird to do an XLOOKUP where the two things are not fully aligned like this, but it is a perfectly valid method, and it works very nicely when you've got a model like this. Returning from there, we're going to lock a couple of things. Lock that, lock this. And then we want to bring the format down here. Whoops. And that gives you your summary by month. Is that working correctly? Yeah, these are changing. Okay. What is it? Oh, total production in pints. Fine. Yes, yes. I was wondering why this was the same every month, but yes, you brew 12 tanks every month. And then you could also do a summary by beer if you felt so inclined. So just equal B, and then we can just say sum ifs, whole range of the model, boom, where, sorry, I did not mean to lock both parts of that, just to lock columns, where column C, and that we do want to put a dollar on, is B. And then again, we just need the format, and then we can fill that formula across. Sorry, I didn't actually do what I wanted it to. There we go. And you could even add in total at the bottom here. B, HBD, and if we've done this right, that'll be the same as the total here. And it is, hooray. Anyway, none of this stuff down here is actually necessary to answer the question. It's just, there's some value in having these summaries if you want to build your model that way. The alternative is you can just, nuke all of the extra copies of month and just do this whole thing as, what are those zeroed out when all I've done is hidden it? That's really, oh, sorry, yeah, because I'm using subtotal. Okay, well, I'll explain that in a second. But anyway, you can just basically take this whole row and put it all into a data table to give you all those values for each month. Now, yeah, I did a subtotal here instead of a sum because I wanted to be able to do one big subtotal down at the bottom. To get an overall total. And the nice thing about subtotal in this respect is that it ignores interim subtotals. So this is just another way to get this total here, this total here. You can get it in, you can get it straight with subtotal. But the disadvantage of that is that when I hid all of these rows, all those subtotals became 0 because subtotal ignores hidden rows, and so these all zero out. But anyway, that's fine. Either delete them and build this as a data table, or don't delete them. And then you've got your summary by month, summary by beer down below. And you'd want to add some kind of section navigations and other things to make this easier to get around. Actually, let's just do this. The easiest thing is just put them into the first column, and then we can have model by month, and then you can navigate in the first column, model by month, summary by beer. Anyway, this ended up actually, even though this video has been longer than I intended to, this is still less time in total than I spent on this question on the day by a few minutes. So that tells you just how long it took me the first time around. But I've spent most of the time today talking about alternatives and model logic and why you'd want to build things this and that way. But I think in terms of competition, this was probably the right idea. Might have done it a little bit more manually than kind of naming everything and so on. Maybe you just kind of copy value paste the pub name to fill this in, for example. But basically, I think unwinding it into a database was the right idea. And this, I could have just built this piece and then data table to get the overall answers. But the rest of it is just more like what would you try to build in the real world? Anyway, that's all I got for today. Like I said, I'm on live stream on Thursday, and I've got another interesting interview lined up for Friday. So see you next time. Bye bye.